You said trigonometry. I said trigonometry.
You need to add units to the fourth.
Can we zoom through the lessons like we did yesterday?
Probably.
Yeah,
So, here's the thing. If we're going to reference the unit circle that we haven't learned about yet, quote unquote,
Wait, we learned about that.
Yeah.
and if we want to, I don't think CPM taught you about it yet, did it? Well, yeah, so that's what I mean. You can draw these triangles just like this, or you can draw your 30-degree triangle pointing the same direction as the 45, like it would do in the unit circle in that top right quadrant where things are positive. So if you want, we can do that with 30 degrees and this being 1. So here, instead of the hypotenuse being 1, like what we talked about in the unit circle, we've made either, well actually for both of them we made the height. Okay, the height is 1. So we're going to do sine and cosines, and maybe a little tangent at the end, and see what we notice. So we can probably fill in the other sides of our triangles.
Opposite over hypotenuse.
That was a Perry teacher who's in charge of their math counts team, because they have kids who want to go to competition.
Do you have kids that want to go to competition?
No, I don't. I begged you guys, and you said no.
Dude, why would you
It's online this year, so actually I don't totally disagree with you. Online stuff is a little lame. So if I look at that 30, 60, 90, what are the other sides of it?
1 radical 3 and
2.
One right. So this is kind of like the unit circle, I guess, just doubled, right? If you said this is 2 and this is radical. What's radical 3 approximately?
I remember.
Just like if we're referencing which is bigger and which is smaller.
Radical 3 is
1.7320.
Yeah, so it's approximately 1.7, right? So keep that in your mind because always we want to make sure the hypotenuse is the longest. So we want to make sure we put things in the right place. So for our 45, what's the hypotenuse there?
it's radical.
It's radical 2, right? Because it's radical
On
2
this
times
side,
1.
you're never going below.
It's so weird, like when you think about how they like got it so that the calculators know what the number is that's the square root or something.
Right. I mean, it kind of works it backwards, right? We're saying if x times x equals 3, what is x? Right? Like, does 1.5 work? No. Does 1.6 work? No. 1.7, we're getting there, right? And you kind of like, yeah. But you could look up how that actually happened. I don't know why I'm so fascinated by this string of paper. All right, so sine, cosine, tangent, SOHCAHTOA, if you will. What's sine of 30?
2.
Sine of 60.
I was going by ABC.
Hmm?
I was doing
What do you mean? Oh,
yeah.
cosine of 30?
It's the same number. It doesn't actually matter.
What? What do you mean? Sine was opposite. Oh, wait. Sine is opposite over hypotenuse. Are you sure sine of 30 is 2?
No, sine of 30 is a half.
Oh, yeah.
You got the first one wrong.
Wait.
I'm a little nervous now. Sine of 30.
Yeah.
Opposite over hypotenuse.
Yeah, so then you switch it.
What do you mean you switch it?
Wait, what?
The sine of a theta angle
Oh, that's what they
is
okay,
the
I get
ratio
it now.
of opposite over hypotenuse. Maybe I need to turn off the jazz. Maybe this is affecting our math.
It is.
Yeah. was affecting my math is officially killing me, but no.
I'm sorry.
That's a bigger ass. I did not use
Sine of 45 degrees and cosine of 45 degrees. That's funny.
So cosine of 30, then adjacent over hypotenuse, so rad 3 over 2.
Fractionate.
Yeah. Tangent 30? Tell opposite over
Wait,
adjacent.
I remember there was a thing. I forget it, and I don't really care about it as well.
I feel like we don't really need both sine and cosine. They're just like a convenience thing. Like,
So what's the cosine or the sine of 60?
it's the same as the cosine of 30. Because it's the same measure.
What's the cosine of 60?
It's the same as the sine of 30. No.
And the tangent of 60?
Wait, it's not that.
What?
Oh, wait, is it? Oh yeah, I'm just not very smart. Okay.
Well, I don't know. You tell me.
No, I flipped sine and cosine. Wait, did I? Did I flip sine and cosine?
I'm just doing what you tell me.
Wait, no, I didn't. The sine.
Wait,
it's
stop!
the
You're
cosine.
confused.
Not the sine of 30.
60 sine is opposite. That,
I
no,
may have
you
misspoken.
switched them.
I
Oh
may
my
have
god.
misspoken. I'm not sure.
Okay, that
Wait.
is.
I meant it was the cosine of 30.
Jake's like, if there's one thing I know, it's the tangent of 45. We're up here fighting with D and E, and Jake's down here. You guys. Opposite over J. Okay, so this is 1. Let's come back up here.
Okay.
Sine of 60.
Sine of 60.
60.
Radical 3
Opposite.
over what? Over 2.
Yeah. The cosine of 30.
And then this would be the
It might
sine
have
of
been, but I just
sine
you
of
said
30.
it's the same, so I looked here. And,
Oh,
It's
no.
the sine of 30.
Okay.
And then,
so these go together.
Yeah, those ones are the
These
same.
go together.
and then the tangent.
Tangent of 60.
That one's
One
not
over
the same.
radical
It's
Oh, so that is the
No,
same.
it's radical 3 over 1.
Wait, okay, so it's the reciprocal.
Yeah, that's what we learned. That's what
So
we
it's just radical 3. You know, I guess you put that over 1.
So wait. Cosine of 30 versus sine of 30 are not reciprocals, though. Cosine of 30 and sine of 60 are the same?
Yeah, because they're the same angles being related. They're the same sides being related. Because the opposite of 60 is the same as the adjacent of 30.
Okay.
Yeah, what they
And the hypotenuse is the same.
So wait, sine of 45, cosine of 45?
Well, those are just the same. It's like
Same what?
they have the same angle.
1 over radical 2.
I was about to say, I don't have 1 over radical 2 anywhere.
Well,
Oh,
no,
these are the same as
they're
each
the
other.
same as each other. Yeah, I forgot what it was.
Okay. Interesting.
because the signs are the same.
I wonder if there's a way that we can apply this conveniently.
Probably can.
What if I was like, nope, there's no way.
There is one. It's you don't have to use sine and cosine.
We don't have to use sine and cosine.
We
You mean we
gotta
don't have to
use
use either of them? Or we don't have to use both?
We don't have to use
Not
both.
for
You can only
36
use
triangle.
for any sort of triangle. All you need is one of them.
So, the Pythagoreans that we discussed yesterday in the past couple days did a lot with sine and cosine, and especially with triangles. Right? Triangles. So, the sine of 30 degrees squared plus the cosine of 30 degrees squared. So, if we say theta is allowed to be 30 or 45, right? That's why they're using theta up here as your reference point. But let's say it's 30. Go ahead and figure that out. What? So we said sine of 30 So write this down for a second. Sine of 30 squared, cosine of 30 squared. We're going to sum the squares. There's this kind of cute scene on Young Sheldon. I don't know if you guys ever watch Young Sheldon. Where his teacher talks about the sum of the squares, or the square of the sums. Like, she says it wrong. And he's like, I'm going to give you a moment to think about what you said. Because she says the statement backwards, and he gets sent to the office.
Yeah.
So,
I thought he was in college.
we're going to sum, this is when he was in high school.
Oh.
We're going to sum the squares, right? So we're going to square first, then we're going to sum them. So what was cosine, or what was sine of 30?
1/2.
So 1/2.
Like Sheldon in college at like age 9 or something.
Well, he gets mad at his parents for not letting him go to college, and then they let him go to college because his high school essentially kicks him out. He's just too smart. They're like, we're done teaching you. We have nothing else to teach you. What was cosine of 30?
Radical 3/2.
Radical 3/2. Now, when we square fractions, how do we do that?
You do it at the top and the bottom.
Yeah, square the top and the bottom, so this
So
becomes
it's
1/4 plus
You get 1.
3/4.
Whoa!
And this is actually exactly what they're discussing in that episode of Young Sheldon, where she says the sum of the squares, well, she says the square of the sums is equal to 1, and what she meant to say is the sum of the squares is equal to 1.
Wait, so.
Does that work for 45 too?
Let's check.
1 over. Wait, is it right?
Yeah, it does.
1 over radical 2. Oh, this is the half of the.
Cosine of 45? Well, you guys said those were the same.
Yeah,
didn't you?
it is 1.
I already said that.
I know you did, but I just figured it out.
This
Amazing.
is famous.
It is. So
What's it?
This, well, what, do you guys remember what we call most things that equal 1 or involve 1?
Zero.
The big one.
Like,
Mono.
one, I am 1, right? 1 is me, I am 1. When you're talking about yourself, it's
Mitosis.
your, starts with an I, it's your,
Individual.
Identity.
identity. So, on your paper, go ahead and write down, this is what we call the Pythagorean identity. That the sine of an angle plus the cosine of an angle that we normally call theta. When we square those values and then sum them, it's gonna equal 1.
My question is, how is this useful?
You tell me.
No, I was asking you.
No, but I'm asking you.
You can solve equations using it.
You can know what equals what?
Well, let's back up a couple
You can
slides.
know if you got the right sine and cosine?
So wait, would that mean sine theta plus cosine theta equals 1 because if you square root both sides?
Wait a second.
Does square rooting a sum work the same as square rooting a product? I mean, this is what I'm asking.
I don't think so. No, I forgot.
So, what if we didn't know the lengths?
That'd be mean.
Right, if we got theta, and we've got cosine of theta squared plus, or sine of theta squared plus cosine of theta squared, it doesn't really matter about our order. So I could say it backwards if I wanted to. So, we could try this with angles that we know, but what if we don't know the angle? Right, and what if we say ABC? So, sine of this theta, that's a highlighter.
Wait a second.
Sine of the theta is opposite over hypotenuse, so A over C. Cosine
I feel like this is going to be Pythagoras.
is like B over C, right?
All of them, it's all coming back to Pythagorean.
Well, that's because it's called Pythagorean identity, so.
If you square them all and then you multiply both sides by c squared, you get the Pythagorean theorem.
Okay, that's what I thought. And C at the bottom, so it's has to be something like that.
So you just said we have A squared over C squared plus B squared over C squared equals 1 squared, and then you're telling me multiply both sides.
Wait, why is 1 squared?
Oh,
it
good
doesn't
point.
matter, but.
So what's my bad? I was on a roll squaring things. So we multiply by c squared.
Wait, hold up.
Wait, hold up.
That doesn't make sense.
What doesn't make sense?
Squares don't roll. I made it, Mr. Hudson.
Oh.
I didn't even see it
I
coming.
get it
I did
now.
not see it coming.
That was very something.
That was like something he would say.
You do have that.
I just totally didn't see that one coming. It was like you were around the corner. It was squares don't roll. Yeah, that brings up the whole like first tires were probably a little difficult. Those caveman. I don't know if you've seen the cartoons. Like
Like this.
first tires are like squares or triangles or like other shapes that were not circles.
Cavemen didn't have tires.
Wait, technically wouldn't ellipses work if the car would just go like...
It would like speed up, slow down, speed up, slow down. Yeah, like what? Yeah, it'd be a bouncy ride. So what if we're told
Very nauseous.
cosine of theta is 9 over 41? What is the sine of theta then?
41 over 9 squared.
Let's imagine this.
9 over 41 squared. I'm just gonna keep guessing.
Let's imagine this. There's a triangle, which we know is right, that has a theta.
Well, what if it's wrong?
No, it's right.
Oh, okay.
And cosine is adjacent over hypotenuse.
Not
Isn't it 41?
Yes. Although 14 could work too. That would be an acceptable hypotenuse with a leg of 9.
It's 1600, 1680 first.
First.
Wait, what?
1 minus 9 over 41 squared.
So wait, if I'm not quite wait, okay. What'd you say?
1 minus 9 over 41 squared.
1 minus 9 over 41.
Oh, I see.
So it's actually the square root of...
Oh, you're saying they're like somewhat complementary in a way. They like add up to 1.
Yeah, so it's 40 firsts.
But wouldn't you have to square it first and then...
40 firsts.
Can't you just use Pythagorean theorem?
Wait, if we're gonna talk in 40 firsts, I don't think it'd be 40 firsts.
It has to be less.
How much more do we need to get to 41 if we're at 9 right now?
I mean, we need...
Well, it's not going to be that same number, though. Will it?
Well, if we said, wait, no, it's the squares.
I think what we have to do is we have to square 9 over 41, and then 1 minus that, and then take the square root of that.
Which is what I
Okay.
did, and I got 40 firsts.
Did you square 9 over 41?
So, the trap.
Can't you just use
What's
Pythagorean?
a svar bracket?
Oh, it's in Swedish, so it's math bracket.
Oh my god.
Oh yeah, my calculator's in Swedish. Just a little thing. The trap. It's a trap. Is not 32 over 41, which you think is like the kind of complementary value,
Well, yeah.
because it's not straight up using that number. It's the sum of the squares.
Yeah.
So absolutely, we square this, we get 81 over 16, 17, 16.
1681 or something like that. I don't know what that's.
No,
1681, yep.
Oh, I did that without a calculator. Let's go.
Let's go.
Where are we going?
My sister-in-law last night sent me this meme that said, millennials will yell "Let's go" before doing absolutely anything. You just did it.
Actually,
I did that math in my head. Let's go.
She did it after.
Yeah.
All right, 16 what?
1681.
81.
Huh. Why did I-
Okay, so then we end up with the kind of the complementary value being 1600
Yeah.
over 1681.
And then you square root it.
So you're telling me this is 40?
Where'd you get the 16?
Bum, bum, bum. Wait, does
Oh,
that
I
work?
see it. I see it. Yeah, no, I see it.
It's less than 49, and it's greater than 31, so it does work.
Or you could have just did 41 squared minus 9 squared and got 1600.
It's greater than...
Okay, so I agree with what you're saying.
50, so it works.
So is this is this useful?
I don't like it because you can just do it easy. Well, I need to reduce it.
Hey, stay with us for just a minute. You'll have some free time at the end of class. Stay with us for just a minute.
Is right. The Pythagorean theorem is perfect. Is there any situation where this might be, where we might not know the sign? Well, actually, it allows us to figure out the sign without actually knowing the sign. Like if we're just given the cosine, but we're not actually given the sign.
I see a problem.
There's a problem.
Oh no.
It says angle theta is an acute angle.
It does, isn't it?
Okay.
This is a Pythagorean triple triangle.
Hold on.
Okay. Oh.
If angle theta is an acute angle, does this make sense?
Yeah. Because the cube doesn't mean less than 45 degrees. It's less than 90. I would hope angle theta is an
So
acute
it's
angle.
not the small angle. Or acute just means less than 90. So that's the other thing that in previous years kids have been like, wait a minute, shouldn't that be the short side because hinge theorem? And no, acute just means less than
If
90.
it's an obtuse angle, that would be a problem.
It would.
So
That would mean not right triangle.
yeah, the thing we care about is it's a right triangle. This is kind of silly because it has to be acute. This is
Or it's not a
unnecessary.
triangle.
Right.
Or
This.
right.
So this is where people put in extra words, especially in those state tests. Don't pay attention to the distractors. Do what you know. Don't get hung up on this. But acute just means less than 90, right? So this is fine.
Wait, we're done. Can I do something else?
Whoa.
Oh.
Please.
We got to decide when we take your chapter 5 test first.
So
you guys got to tell me.
is all what our homework from last chapter is doing?
Yes.
Oh, okay. I think I have that.
We already know this.